One of the constants in life is change, and virtually everything on earth changes. Perhaps you can tell what gives change its significance. It's time. Everything done with time either yields a positive or negative result. Examples of such things are success in any given endeavor, growth in capital, or even in living organisms. On the other hand, time also determines failure, wastage, or eventuality. All of these are determined by the way we handle the treasure called time. As with time, there are different variables in life that determine the outcome of other things. Let's see an example. The amount of moisture in processed cassava flakes, otherwise known as garri, depends on the amount of heat applied. In this instance, a change in the amount of heat causes a change in the amount of moisture in the garri. What happens here is called differentiation. In mathematics, differentiation is the process of finding the amount of change in one variable caused by a change in the other variable. Differentiating a function is the same as finding the derivative of the function. In this lesson, we will focus on the differentiation of polynomials. To begin with, what is a polynomial? A polynomial is a function or expression with many terms. An example of a polynomial expression with two variables is x squared minus 2xy plus 2x plus 5. Furthermore, you can have polynomials with more than two variables. Mathematically, a polynomial with one variable is written in the form anx raised to power n plus an minus 1x raised to power n minus 1 and so on, plus a0x raised to power 0. Let's move on to differentiation of polynomials. We have already learned that the derivative of x squared is 2x. Generally, polynomials are differentiated by multiplying the coefficient by the power of the variable and then reducing the power by 1. Therefore, for any function y which equals ax raised to power n, dy dx will be equal to anx raised to power n minus 1. There are certain rules that are used for differentiating polynomials, and they include the chain rule, the product rule, and the quotient rule. The chain rule is used when an expression is raised to a power greater than 1. So, if y is equal to an expression f of x raised to power n, we make f of x equal to any function t, such that y will be equal to t raised to power n. Hence, we differentiate y with respect to t and differentiate t with respect to f of x. Finally, the product of dy dt and dt dx is simplified to get dy dx. The product rule is used whenever two or more expressions are multiplied. It states that given any function y such that y equals uv, then dy dx will be equal to v du dx plus u dv dx. The quotient rule is used whenever an expression divides another expression. It was derived using the product and chain rules. It states that for any given function y such that y equals u over v, then dy dx equals v du dx minus u dv dx over v squared. In summary, we have learnt about differentiation, polynomials, and how they are differentiated. We also learnt about the chain, product, and quotient rules. I'll be seeing you in another lesson.